Welcome to Miss Taylor's class notes. Today we're going to talk about arcs and inscribed angles. So a quick reminder that an arc is the part of the circle on the outside. It's part of what we call the circumference, and we measure arcs typically in degrees. So the measure of an arc is congruent to the measure of the central angle that makes up the arc. So we just simply find the measure of the angle, and that is the measure of the arc. Now, if we're looking for a major arc, which are named with 3 letters, we know that the whole circle is going to be 360 degrees. So we're going to take 360, subtract the 50 that we know. And so we know that this angle here is 310 degrees, which means our arc is also 310 degrees. And again, our arc addition postulate just says that we can add any 2 arcs together. So let's break this one down into all of its parts and all of its pieces. So the first thing I notice that AD is a diameter, which means my total degrees of AD, or really we would name it arc ABD, would be 180 degrees, not 88. So that also tells us that this right here is going to be 180 degrees because we know a circle is a total of 360. So I'm going to do 180 minus 55. Let me grab my calculator real quick. I'm not prepared today, and I don't feel like doing mental math, is 125. So I know that this angle here is 125 degrees. So that means that arc ED is also 125 degrees. So now I need to find CD and I need to find BA. So now I'm going to kind of erase all the other lines that I've drawn on this so that we can look at this from a different perspective. So now I notice that CE is a diameter. So I know that this angle right here is 180 degrees, and I know that this semicircle here is 180 degrees. So I'm going to do 180 minus 125, which gets me 55 degrees. And if we look, both of these 2 arcs here are made up of vertical angles, which is why they are both 55 degrees. And so now we need to find this last one right here. So this angle and this angle are 55 and 30. So we're going to do 180 minus 30 minus 55. And we're going to get 95 degrees. So again, once we find the central angle, we can find the arc measurement. So now let's just kind of go back over and make sure we understand. So the measure of arc CD equals 55 degrees. The measure of arc ED equals 125 degrees. And then the measure of arc AB, again, that's supposed to be an arc symbol, equals 95 degrees. So those were all 3 of our missing arcs. So again, we can do the same thing right here. And we know that all of the angles in a circle equal 360. So we're going to simply say 360 equals 5x plus 40 plus 70 plus 75 plus 2x. So we combine all of our like terms. 40 plus 70 plus 75 is 185. So 360 equals 185. And then we're going to add our x's plus 7x. And so now we can just simply solve. Minus 185 is 175 equals 7x. And then we divide by 7. Which gets us x equals 25. So now we can plug in our 25 here. And then we should get 125. And then we plug in our 25 here. And we should get 125. So, yep. And so those are the missing measures, and those are our arcs. And again, our central angle is the same as the arc. Our central angle is the same as the arc. So now we're going to talk about inscribed angles and intercepted arcs. So an inscribed angle is an angle whose vertex is on a circle. So because our B right there is on the circle, that makes angle ABC an inscribed angle. And the other thing that we're looking for is it's going to contain two chords. So the side of our angle are going to be two different chords, which are lines that have their endpoints on the circle. And so that's just what an intercepted arc is. So what we know about our inscribed angles and their arcs. So if we have angle D right here and we say that angle D is X, then we know that arc AB is 1/2 of X. We can also look at it, is 2 of X. But if we look at the other way, if we say that AB is X, then I know that my angle is 1/2 of X. So if we're looking at this right here, we've got our arc, and we know that our arc measure, so 40, is 1/2 of X. Or sorry, an arc, 40 is 1/2 of the angle. So 1/2 times 40 is 20. So the measure of angle JKL equals 20 degrees. So here they give me the angle. And so I know that the angle is going to be multiplied times 2 to get me the arc. So 72 times 2 is 144. So 144 degrees equals the measure of arc D, not EDF. Ugh. All right, so inscribed angles of a circle. So if I have two inscribed angles of a circle that intercept the same arc, then the angles are congruent. So we're going to look at angle ADB, and its intercepted arc is AB. And then we're going to look at ACB, and its intercepted arc is also AB. So if they share the same arc, then we automatically know that the two angles are congruent. So if we're looking at this right here, I'm going to start with ABD. So our intercepted angle, and it's going to intercept arc. So from endpoint to endpoint is AD. So I'm looking for another arc that starts at A and ends at D. So that tells me that this right here. So I know that angle ABD is congruent to angle ABD, ACD. But if we look at it this a different way, different color. So if I look at angle BAC, I'm going to pick a different color for my highlighter. So we're looking at arc BC, and now I'm going to look, is there another angle there? And so we've got angle BDC. So those two angles are congruent to each other. So angle BAC is congruent to angle BDC. And part of what you're going to be looking for is you're going to be looking for, are the first and the last letters the same? Are the first and the last letters the same? Because those are going to be the endpoints of your arc. And so, yeah, that part should go right there. So now, we can, instead of inscribed angles, we're going to talk about an inscribed polygon. So an inscribed polygon is where all of the vertices lie on the circle. So all the corners of our shape are going to be on the circle. That's how we know it's an inscribed polygon. So if it's a quadrilateral, we know that it's inscribed if and only if its opposite angles are supplementary. And remember that supplementary equals 180. So that means that D plus F equals 180. And that means that E plus G equals 180. So let's do this right here. So we know that this is all of its vertices or its endpoints are on the circle. So I know that opposites equal 180. So 180 minus 100 is 80, which equals 80 degrees is the measure of angle N. And then again, we know opposites are 180. So 180 minus 65. Oh, come on. Is 115. And so 115 degrees is the measure of angle M. So now let's talk about right triangles, because right triangles have some of their own rules. So if a right triangle is inscribed in a circle, then the hypotenuse is the diameter. So when we're looking at right triangles, we're looking for a triangle where the longest side is the diameter, and that immediately tells me that it is a right triangle. So, yeah, so that's what we know. So we're going to look at this one here. So here I have a triangle, and if we notice BC is our diameter, and so that means the angle opposite of the hypotenuse or opposite of the diameter is my right angle. So if I know that this angle is 90 degrees, then I know that this arc right here is going to be double my angle, and so that arc is going to be 180 degrees. So if we're looking at this right here, I know that my angle, again, let me change colors, is going to be half of the arc, so I need to double the angle. And so 56 degrees is that arc right there. And so now we can do our math because we know the whole thing equals 360. So we can do 360 minus 180 minus 56, which tells me that this arc here is 124 degrees. And so if the arc is 124 degrees, because it's incepted by that angle, we can take the 124 and divide by 2, which tells me that that angle right there is 62 degrees. And since we know it's a right triangle, we can use our Pythagorean theorem to find our hypotenuse. So 3.9 squared plus 7.3 squared equals c squared. And so we know that c equals the square root of 68.5. And so that's everything that we need to know about arcs and inscribed angles.